All right, so we're going to take a look at 8.3 graphing. Now, what is it that we're graphing at this moment? Well, notice that we have finally added in this b term. Recall the transformations that a does. Remember, it causes your parabola to either get real skinny or possibly really wide. It also can turn it upside down if the a value was a negative, so it could be an upside down parabola. And then in the 8.2 lesson, we talked about how the C value, based on it being a positive or a negative, simply took the parabola. And if I were to draw one of these, here we go, it would take it and simply just move it up or down. It doesn't do any left or right, it's just up or down. If it's a plus C, it moves up. If it's a minus C, then it moves it down. That's all the C value does. So now we want to get to this B value. And we're really looking for the idea of where is the vertex? Where is that very bottom point for a parabola that opens up? Now, if a parabola opens down, we're looking for that very maximum point. So we're either wanting a minimum or a maximum. And the B value helps us find that vertex. But the V value does actually more than that, but we're only going to really focus in on this vertex idea because it does control the left or right shifting of a parabola, but it does it very oddly. So instead, we're going to focus on what does it help us do to find the vertex. So I've decided to kind of break this up into some of the key components. The first is let's look at a comparison between the original parent function y equals x squared and one that has some transformations done to it, this x squared minus 8x plus 7. First off, we would already know some of the transformations. We would know because the a value is not written that it's a 1, which means it's not going to get skinnier and it's not going to get wider. It's just going to be the standard, just like the parent function up here. However, we see this plus 7 and know that, oh, it's going to do a shift. In fact, it's going to do a shift up because it's a plus. It's going to shift it up 7. Or better words, now that the B value is here, it would be better to say that it's going to intercept the y-axis at 7. So what I decided to do is this first time I would say, all right, well, let's take some points and plug them in for the x's. As you can see, I plugged them in for the x's and I did the math and I found all of the outputs and I graphed it. I made a t-table, picked some points and graphed them. And I got this as my result. Now, notice the details are still there. Notice that the parabola still opens up. Notice that it doesn't look any wider. If I go over 1 and up 1, the graph is still there, just as it is on the original parent. If I go over 2 on the original parent, I would still go up 1, 2, 3, 4. And I go over 2 on the new graph, I would still go up 1, 2, 3, 4. So this one is not any wider or narrower than the original parent. And then notice this plus 7. Now, because the B value is here, this 7 just acts like the point that it touches the y-axis. And notice that is 7 units up. 1, 2, 3, 4, 5, 6, 7. So it's still controlled an up and down movement. It's this B value that's kind of strange. And we'll later on learn a little bit more about the B value. But right now, we have the details that we could start to write down to describe the transformation. We could say, first off, that it translated up 7 units. Now we know that it does have some horizontal shifting. And this is a little bit harder to see because it's not a direct sideways. It's kind of more of an angled action that happens. But I do want to point out some details. Notice where the vertex ended up at. Notice the vertex and where it ended up at. Notice that it is horizontally 4 units over. Okay, so the x value of the vertex is 4 units over. So when we write a vertex, we of course write it as a parenthesis, x comma y. So my x is a 4. It moved horizontally 4. 1, 2, 3, 4. Now, if I describe the axis of symmetry, it is that position 4, that y equals x. In fact, I want to kind of put that onto here because this is important for us. The axis of symmetry is x equals, what position was that? It was 1, 2, 3, 4. So x equals 4. Now, though, what about the y value of the vertex? Because remember, this section is really focusing in on how do we find the vertex? Well, if I have to go over 4, how far down do I have to go? Well, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 units down. So it's a 4 comma negative 9. Now we should answer this question, is it a maximum or a minimum? Well, since the graph opens up, this is the lowest point I get to. So it is a minimum. But now let's kind of try to talk a little bit more about the vertex and how to get to it. Because we want to know, how can you find the vertex just directly from the equation? Well, notice the first key piece, that the middle of the graph is between the two spots it crosses the x-axis. They are both 1, 2, 3 units away, 1, 2, 3 units away from that axis of symmetry. In this case, they're both 3 units away. So there is one little clue about how to find the vertex. It will be halfway between where it intercepts the graph. But you could just do what I did. Pick some points, plug it in, and hopefully you find and graph it where the very bottom is. This is an acceptable method to kind of just begin with. So what I'm trying to tell you is that there are multiple ways to find the vertex, one of them being graphing it by hand. Pick some points, and hopefully you will find one that obviously tells us where the vertex is. Let's answer a couple more details about this graph before we go to another way to describe the vertex. First off, we want to know, where is the function increasing? Now, in a previous video, we talked about where do you have to ride the bike uphill. So if I were to draw a bike, and again, this will be a terrible looking bike, but whatever. There's my bike. If I'm going to ride the bike, where do I have to ride it uphill? Well, would it not be here that would be going uphill? So this is where the function is increasing. But when does that increasing start? Because right here at the bottom, at the vertex, it is flat because I've just come down the hill and I hit the bottom. I'm flat for just a moment, and then I have to go up the hill. So it really starts right there at the vertex, which we said was a position of 4 for the x-coordinate. I'm going to move my bike out of the way because I'm going to need to grab it again. Here we go. So it's increasing. So the function is increasing on any value of x that is greater than position 4. What about the decreasing, though? Well, I'll go back to the bike. When do you ride the bike down the hill? Well, it would be here. You're riding the bike down the hill here. And you're riding it down from really high up all the way until you hit, again, the vertex. Because the momentary spot at the vertex, the bike is flat, and then it starts to ride back uphill. So It's decreasing for any x value that is less than 4. Now, some have asked me what happens at exactly 4. Well, because the bike is flat at exactly 4, it's neither increasing nor decreasing. Last but not least is this domain range idea. This came up in the other sections, especially in the homework. What's the domain? Well, domain really means what x values. When you follow yourself along the x axis, either left or right, will you run into a time when you would follow the grid pattern up and not find the graph? So if I go back here to position -10, if I go up following this grid line at position 10, eventually I would run into this graph because the arrows tell me it keeps going. I might have to go way off the page, but eventually I would still run into it. Well, the same thing would happen if I went way back over here to position what, -20? I would still go up, but it would be a long ways, and I would still run into the graph. And I could do that even further out at -1,000. I'd have to go up a long ways, but I would still run into the graph, which means the domain so far can be any negative number. What about the other side? What about the positives? Well, the further I go out, I could still follow one of the grid lines, such as position +10. I'd follow it up a little ways, and then I would run into the graph, because remember, the arrow tells me it keeps going. Well, when I get further over, I could go over to positive, let's say this was +30, and I'd follow it up. I'd have to go up a long ways, but I would still find the graph. And I could do that at +1,000 and a +10,000. I could still eventually find the graph. Since I can go in either direction, on the positive side or the negative side, and always find the graph, my domain is oftentimes listed as all real numbers. The only time it will not be all real numbers is if somehow there is a gap. If somehow we have a whole section on the graph that we don't work with. In general, though, parabolas, the domains, are all real numbers. What about the range? Now, the range is kind of doing the same thing, except for this time we're looking at the bottom and the top of the y-axis. And we follow the horizontal grid line and look left or right and see, do we run into the graph? Well, down here at position -10, if I follow the grid line horizontally, I do not see the function at all, so it doesn't exist. But if I go up one position to this -9, oh, look at that. I have to look just a little ways to the right, and sure enough, there's the graph. And when I get up here at 0, I look to the right, I can see the graph, and I go up further and to +10, and I can look left or right and see the graph, and I can go up to +100, and so forth, looking left and right and see it. Basically, anything beyond this -9, I would see the graph, but anything below that, I would not. That is the description of the range, saying that I can look at any y value as long as it's greater than or equal to -9. I say or equal to because at position -9, it sure enough touches there. So it has the or equals piece to it. All right, let's go to this idea again about finding the vertex. This time I didn't do the entire problem. I just did a fair amount of it. Notice that I went about this finding the vertex a different way. I decided that since I learned from the last problem that the vertex is directly between the two x-axis intercepts, what if I just decided to find the x-axis intercepts? How do we do that? Well, look at this. We factor it. And I found that the graph crosses at 1 and at -3. So if I were to graph that, it crosses at 1 and it crosses at -3. That means my vertex has to be directly between those two, which is this line of x equals -1. And I'm going to do that. I'm going to graph this. I'm going to put this on here. That is my axis of symmetry. X equals -1. And the vertex has to be somewhere along there. The only thing is I don't know where, but I can find it. Since I know the x coordinate, what if I plugged it in and solved it? Then it would tell me my y coordinate. So I'm going to do that. I have y equals negative times -1 squared minus 2 times -1 plus 3. There we go. I'm going to zoom in on it now. If I find the answer to this, I will know exactly where my vertex is. -1 squared is a positive 1, but there's a negative on the outside, so it's really -1. Then I have -2 times -1, which is really a positive 2. So what's -1 minus plus 2? -1 plus 2. Well, that's just 1. Then plus 3. It is a 4. So that means that my vertex, my iPad seems to have frozen. No! There we go. That means at position -1, I go up 1, 2, 3, 4, and there is my vertex. Which means I can answer the question down below. Zoom out enough to see it. There we go. The vertex. Well, we know it's an x comma y, and we know what the x was because we found it by finding the middle between the two intercepts. It was position -1. And then we plugged that in and found how high or low it was. In this case, it was a 4. Now, here's the thing. I didn't talk about the transformations, but when I go to graph it, I can now see one of the additional transformations. Notice that the parabola is upside down. And notice that it had a negative in the A position. I even said the A value was -1. So I should have known that it was upside down. They call that an x-axis reflection. Notice too, it's a +3, which means it's going to cross the y-axis at a +3. And notice it does that. 1, 2, 3. It's crossing right there. So transformations, we are first going to have an x-axis reflection. Then we also said it was going to translate up 3 units. Now, based on our position, is it a maximum or a minimum? Well, if the graph keeps going down, then when I get to that position of the vertex, it's really a maximum because then I start going down again on the other side. So it is a maximum. Where is it increasing? Where is it decreasing? I'm going to grab my bike again. Well, this time it's the other way around. It increases. It's increasing all the way up till I get to the vertex, the top of the hill. So it's increasing from really, really far down from any x values that are before position -1. So it's increasing for any x values that are before or less than -1. What about decreasing though? Well, it's the exact opposite. It's decreasing where I can ride the bike, where I can ride the bike down the hill. I can't seem to be turning that at this point. Down the hill. So it flat right there at the vertex, and then I get to go down the hill. from then on. So it's decreasing from any position of x greater than -1. Domain and range to kind of finish this out. Domain, if I keep going backwards, will I still find the graph further and further down? Of course I will. Doesn't matter how far over I go, I will still have to look really far down and find it. Same thing for going forward. Doesn't matter how far forward I go in the positive x's, I'll eventually find the graph further and further down. Again, describing for us all real numbers for the domain. What about the range, though? Well, again, I follow the y-axis from the bottom up. And yes, I could look sideways and see the graph because my arrows tell me it keeps going, so I could still see it. But by the time I get up to this position, 4, I see the graph, but then beyond 4, I no longer can see the graph. So I can take any y value that is, well, from 4 and below. I can take any y value that is from or equal to 4. All right. Now, we talked about 2 methods. One, graph it. Find some points, plug it in, and see if you can find your vertex. Not super effective, but if you don't know what else to do, I guess that's a good starting point. The next method is to take your equation and factor it, because we know that the vertex will be exactly between the intercepts that we spent a lot of time finding in chapter 7. Good method. However, it's very time consuming. The next video, we will talk about a way to kind of use the pattern of what we're seeing here, use the pattern that it was established by former mathematicians, and see a much faster, more effective way to find the vertex. All right, thank you for your time.